Alright, so I want to talk about how to evaluate the trig functions going around the unit circle. But first we need to talk about what they represent. So let's just make ourselves a little list. Sine, cosine, tangent, cosecant, secant, and cotangent. Glad you can still see this. So sine is found by just looking at the y value at the angle theta on the unit circle. Cosine is the x value, and tangent is y over x. It's sine over cosine, in other words. Cosecant is the reciprocal of sine, so we take sine and flip it, get 1 over sine, or sorry, 1 over the y value, which is 1 over sine, so I guess I didn't really misspeak there. Secant is 1 over the x values, and cotangent is the reciprocal of tangent, so that would be x over y. So let's say we want to evaluate some trig functions. We can use this information here to help us do that, and use our unit circle's coordinates to speed up the process a little bit. So for example, let's say we want to know what is the sine of 2 pi over 3. Well, the first thing we got to do is take a look at our unit circle and try to find 2 pi over 3. So you can see it's up here. This is in the second quadrant. So we said just a second ago that sine is the y value. So if I'm looking at 2 pi over 3, the coordinate there looks like this. The y value is obviously the square root of 3 over 2. So therefore the sine of 2 pi over 3 must be the square root of 3 over 2. And that's really all there is to it. So let's do a couple more. Cosine of, I don't know, 5 pi over 6. Well, first thing again we want to do is find 5 pi over 6 in the unit circle. Again, it's in the second quadrant, right here. Notice that cosine, we said, was the x value. In this case, that's going to be negative square root of 3 over 2. I don't know how well that's picking up on the camera. Yeah, I guess you can see it. So, cosine of 5 pi over 6, cosine in that quadrant is negative, so we get negative square root of 3 over 2. Alright, so it's not really any big deal there. Let's do a couple more. Let me say tangent of 5 pi over 4. So we first again need to find 5 pi over 4 on the unit circle, and then look at, we said tangent was y over x. So let's take a look. See, 5 pi over 4 is down here in the third quadrant. It's right there in the middle. So we said it's y over x. So we're going to get negative square root of 3 over 2 over negative square root of 3 over 2, or sorry, I misspoke there. Square root of 2 over 2 over itself, and that's going to be 1. Anything divided by itself is just 1. So the tangent there, so it's going to be positive 1. Let's do one more with radians. Let's look at a cosecant. Cosecant of, and let's actually do one that's not even on the circle. Let's say 27 pi over 3. So obviously, if you know the unit circle at all, you know that there's no 27 pi over 3. So you have a couple options here. You can just take the unit circle and start counting your pi over 3s. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, etc., etc., all the way around the circle. But that could take a while. So instead, what you can do is, well, we know looking at our unit circle, there are 2 pi radians in the whole thing. You go all the way around, you'll get back to 2 pi again. So what you can do is, you can subtract 2 pi from this number here. So if I got 27 pi over 3, I'm going to subtract 2 pi. Remember, in order to subtract fractions, you have to get a common denominator. So it has to be a denominator of 3, and 6 divided by 3 is the same thing as 2 pi. So we subtract and we see that that's equivalent to 21 pi over 3. Unfortunately, 21 pi over 3 is still not on the circle. So I'm going to do the same thing again. I'm going to subtract another 2 pi. So go around the circle one more time. And then I get 15 pi over 3, which is still not on the circle. So I do the same thing again. Subtracting 15 pi over 3. And I get 9 pi over 3. And then finally I start to realize that I could have saved myself a lot of time if I just divided. I notice now that 9 divided by 3 is just 3 pi. So looking at the circle, if I go around 1 pi, 2 pi, 3 pi, I notice that the cosecant there, that's the reciprocal of sine, which is y values. So sine there would be 0. If I flip that upside down, I'll show you here in just a second. And this was 27 pi over 3. So sine of that angle would be 0. If I flip that upside down, 0 over 1, when you flip it, becomes 1 over 0, which is undefined. So cosecant of 27 pi over 3 doesn't exist. But that's a little trick you can do, just subtracting off rotations around the circle until you get something that is on the circle. Or in this case, we could have just divided. That would have saved us some time also. So there's radian measures. You can do the same thing, looking at degrees instead. So you might be asked, for example, what's the sine of 270 degrees? So you want to find that. That's going to be down here at the bottom of your circle. There's 270. Again, sine is the y value. You can see the y value there is -1. So the sine at 270, -1. Easy peasy. Let's say the cotangent of 315 degrees. Again, you need to find 315 on your unit circle. 315 is right here. Cotangent is x over y. So root 2 over 2 over negative root 2 over 2. Well, you're dividing something by itself, except for the negative there, so that's also going to be -1. Surprise, surprise. And just like with the other thing, let's say you had, I don't know, the cosine of 765 degrees. Well, you can subtract off 1 full rotation in degrees as well. So subtracting off 360 until you arrive at something that is on the circle. So eventually you subtract off and you see that that's equivalent to 45 degrees. So you can find the cosine of 45, which would be root 2 over 2. No big deal. Alright, one other important skill that has to do with this is you might have to rewrite something. So for example, they might say, we know that the sine of 2 pi over 3 equals something. We solved that a second ago. But we want to rewrite this a couple other ways. So we first, in order to do that, need to find out what is the sine of 2 pi over 3. So we said just a second ago that was the square root of 3 over 2. So we want to rewrite this. We want to find other things that are equal to the square root of 3 over 2. And you can do that using your unit circle as well. So for example, here I have a square root of 3 over 2. It's the y value there. So in other words, the sine of pi over 3 has the exact same value as the sine of 2 pi over 3. So I can rewrite it like that. Also see here, I got another one. That's the x value there at pi over 6. So the cosine of pi over 6 has the same value. And kind of like what we saw earlier, we can still add and subtract 2 pi. So go around the circle again. So the sine of 8 pi over 3. If I add 2 pi to that, that should be the same value as well. Also one other trick, looking down here, we have a negative square root of 3 over 2. That's close, except for the negative. So that's the y value. That'd be the sine of 4 pi over 3. So the sine of 4 pi over 3 gets me really close. It's equal to the negative square root of 3 over 2. So to fix that, let's throw a negative in front. So this is also equivalent to the sine of 2 pi over 3. So that's a couple of examples of nice little tricks you can do and how to evaluate the trig functions on the unit circle. So hopefully that helps. If you need to see some more examples, just send me a message, let me know. I'll hook you up. So there you go.